So in this video, we are going to see an important concept from the chapter number 8, Introduction to Trigonometry. We are going to discuss trigonometric ratios of complementary angles. Now, first of all, let's understand what are trigonometric ratios. So just for the sake of a revision, we know what trigonometric ratios are. Trigonometric ratios are relationships. Okay, they are relationships between angles. Okay, between angles and sides of a triangle. Okay, so we have seen 6 different trigonometric ratios. The basic of those 6 trigonometric ratios are sine theta, okay, and cos theta. These two are the basic ones, and the rest of the 4 are derived ones. I am going to quickly make a note of them. Third one is tan theta, which is sine theta by cos theta, and fourth one is, we can start with sec theta. Sec theta is 1 upon cos theta. Then we have cosec theta, okay, which is, okay, let me write it down, which is 1 upon sine theta. This is 1 upon cos theta. This is sine theta divided by cos theta. And the last one is cot theta, which is 1 upon tan theta. Okay, so once again, trigonometric ratios are relationships between angles and sides of a triangle, and we have seen 6 trigonometric ratios so far. Now in this video we want to discuss trigonometric ratios of complementary angles. But what exactly are complementary angles? So again, what exactly are complementary angles? Okay, so complementary angles are, as we know, as we have seen them previously, complementary angles are any two angles whose sum is 90 degree. Okay, any two angles whose summation is equal to 90 degree are called as complementary angles. So they are complementary to each other. That is their definition. Now let us discuss trigonometric ratios of complementary angles. Let's come down here. Okay, so to do so, I'm going to take a right angle triangle. So let's take a right angle triangle here. Okay, let's zoom in. So this is my right angle triangle. This is the 90 degree angle here. Okay, and let's name it. This is A. Okay, this is okay, let me name it here. This is A, this is B, and this is vertex C. Okay, now we know in a triangle, okay, in any triangle, so sum of all the 3 angles is equal to 80 degree plus angle C, okay, is equal to 180 degree. Okay, now in this triangle, in triangle ABC, B is 90 degree. Okay, therefore now for triangle ABC, angle A plus 90 degree plus angle C is equal to 180 degree. Therefore angle A plus angle C is equal to 90 degree. Okay, thus we have found out two angles whose summation is equal to 90 degree, which means angle A and angle C are complementary angles. Okay, by this definition, what are complementary angles? Any two angles whose sum is 90 degree. So let's come down and let's make a note of that. Thus, okay, thus angle A and angle C in triangle ABC are complementary angles. Okay, this is an important point. These are complementary angles, these two. And now we will discuss the complementary angles. Now we will discuss the trigonometric ratios of these two complementary angles, angle A and angle C. Okay, for that I am going to make a copy of this, copy and bring it down. paste. Yes. So these are my complementary angles. Angle A and angle C are my complementary angles. Now let's focus on angle A to start with. Now for angle A, let's discuss its two trigonometric ratios, sine and cos. Okay. So I'm going to start with sine first. Sine of angle, okay. Yes. Now sine of angle A is equal to, okay, opposite side divided by hypotenuse. So it is equal to BC by AC, okay, and cos of angle A is equal to, so cos of any angle is adjacent upon hypotenuse. So it is going to be AB, okay, it is going to be AB divided by AC, okay. Now let's focus on this angle C and let's find its sine and cos. Let me zoom out a bit, okay. Now sine of angle C is equal to, so C is my angle of focus, so opposite upon adjacent, so that is going to be AB divided by AC, and cos of angle C is equal to adjacent upon hypotenuse, so that is going to be BC by BC by AC, correct, BC by AC. Now note that sine A, which is BC by AC, is equal to cos C, which is BC by AC. I'm going to use a highlighter now, okay. So let's use this highlighter. Yes, so BC by AC, this is also BC by AC, which means sine A and cos C are equal in this triangle. Similarly, let's use a different highlighter. AB by AC, AB by AC, which means cos A is equal to sine C. Thus, for these two complementary angles A and C, angle A and angle C are complementary angles. Their summation is equal to 90°. So this is some special case or special scenario where we discuss the trigonometric ratios of complementary angles. They are having some unique relationship. So as you can see that sine A and A's complementary angle is C. So sine A and cos C are equal. Same goes with cos A and sine C. Okay. So let's try to note it down. Therefore, sine A is equal to cos A. I'm sorry, sine A is equal to cos C, and let's extend this. Yes, and here we can note down that cos of A is equal to sine of C. Okay. Now what I want to do is I'm going to express A in terms of C. This angle A in terms of C. How can we do that? We know, but A plus C is equal to 90. Therefore, A is equal to 90 minus C. Okay, and I'm going to substitute this. I'm going to substitute this in this, and thus sine of 90 minus C, will be equal to cos of C. Okay, I'm going to use the same logic. For this angle A, and I'm going to rewrite it in angle C. Okay, and therefore I'm going to get here cos of 90 minus C is equal to sine of C. And this is the most important conclusion that we were trying to come at or arrive at using our complementary angle logic. So sine of 90 minus C equal to cos of C, and cos of 90 minus C equal to sine of C. So note that for any angle of the form 90 minus C, we change this trigonometric ratio from sine to cos and the angle remains same. Okay, for any angle in the form 90 minus C, so this 90 minus C is actually a complementary angle. So these two complementary angles are related to each other through trigonometric ratio, and that is sine and cos, and this is also sine and cos. So this is a relationship we found out between two complementary angles through trigonometric ratio sine and cos. Okay, now we are going to repeat this same exercise, this same logic for tan and cot, and we are going to find out what is the relationship between them. So let's come to this side. Do we have space? Yes. Or okay, let's go down. No, let's come to the side. So this was my triangle. Let's zoom in. Okay. Yes. So this is triangle ABC which we had, and once again let's, this is angle A, okay, and both, so the important relationship between angle A and angle C is angle A plus angle C is equal to 90 degree. Okay, they are complementary angles. That is the most important relationship. Now let's focus on angle A and let's find tan and cot of angle A. So once again let me draw a line in between here and then we'll start noting down. Okay, so tan of A is equal to, by definition, opposite side. This is the opposite side divided by adjacent side. So opposite side BC divided by adjacent side AB. Okay, and what is cot of A? Cot of A is equal to adjacent side. So this is the adjacent side for angle A. And this is the opposite side. So it's basically the reciprocal of tan A. Cot A is the reciprocal of tan A. That is equal to AB by BC. Okay. Now let's focus on angle C and let's note down the ratios for angle C as well. So similarly we have tan of C. Tan of C is opposite side AB divided by adjacent BC, and cot of C quickly is equal to BC by AB. And again, just like we have noted down before, again here this is BC by AB, BC by AB. So tan A is equal to cot C, and similarly AB by BC, AB by BC. So cot A is equal to tan C. Okay. So once again, let's make a note of this point. Thus we have tan A equal to cot of C, and I'm going to extend this line. Let's extend this line. Okay. Yes. And we have cot of A as equal to tan of C. Okay. Thus we are thus A and C, which are complementary angles, they have this relationship. Tan A is equal to cot C, cot A is equal to tan C. And from this, let me use highlighter. From this complementary angle relationship, we can rewrite this angle A into angle C, or we can even do the reverse. We can rewrite this angle C in terms of angle A, which is basically 90 minus the angle. So therefore, or instead of therefore, I'm going to write but A is equal to 90 minus C, and therefore tan of, replace A by C, 90 minus C is going to be equal to cot of C. Okay. Similarly here, cot of, replace A by 90 minus C is equal to tan of C. Okay, and let's highlight this point, this. Okay, once again this is the trigonometric ratio relationship for complementary angles. So these are two complementary angles as we saw here, A and C, A and C. Now again, using this similar logic, which I'm not going to repeat in this video, but using this similar logic and similar flow of discussion, we can very confidently say that, let me use a different color here, that sec of 90 minus C is going to be equal to cosec of C. Okay, and cosec of 90 minus C is going to be equal to sec of C. Okay, so once again 90 minus C is the complementary angle of C. 90 minus C is the complementary angle of C. So and C can be replaced by any other angle. You can write A, you can even say theta. The value or this variable doesn't matter. So let's use the highlighter to even highlight this point, this and this. So whatever we have highlighted in the pink color, this is the relationship. This is the relationship between the trigonometric ratios of complementary angles, and that was what this video was all about.